And just like before, I'll record this and put it on Classroom for you so you have it for future reference if you need it. So if I'm going to do a problem like this, guys, anytime I see a fraction in an equation or a fraction in an expression, I make it so that everything in that equation or everything in that expression is a fraction. So I would rewrite this as 2 over 1. I'm going to give myself a little bit of space here. And I'm also thinking about factoring as I go. X plus 9, that's not factorable. That's a prime factor. However, x squared plus 9x, we can factor that because there's a greatest common factor that we can take out of that. So we would have x times x plus 9 would be the way to factor that denominator. Now we can start thinking about getting common denominators the whole way through. So if I start kind of comparing what's the same in the two expression or the three denominators, I guess, I can see that in 2 of the fractions I have x plus 9, which means I know that I'm going to need an x plus 9 in this third expression, this third fraction. So I'm going to go ahead and multiply that by x plus 9. And then if I start looking at the rest of it, I see I have this factor of x hanging out by itself. So that means I'm going to have a factor of x as well as part of that denominator. So now I can start looking at how to actually get rid of the denominators. So we talked about this in the video a little bit. You can multiply everything in this equation by the common denominator. And I'm kind of taking some shortcuts here. I'm not really writing out that next step. But if I multiply everything in that fraction, every single term by the denominator, what ends up happening is when I distribute this to here, I end up with a giant 1 here. When I distribute this to here, I end up with a giant 1 again. When I distribute a third time, I end up with a third giant 1. So the beauty in getting that common denominator is that it eliminates all of your fractions. So what I really have here, and remember, so I'm going to show you something here before I just do that and you guys look at me like I'm crazy. In this expression right here, it's all multiplication happening between 3 terms or between 3 things. Remember, multiplying can happen in any order. So instead of writing it as 2 times the quantity of x plus 9 times x, I can rewrite that as 2x times x plus 9. That might be easier to look at. It's a personal preference. You don't have to do that. Equals 3x. I forgot to multiply the top of that fraction by x, didn't I? 3x squared, and then equals 8. So now I've got my expression. It's going to be a quadratic, which means you're either going to have to factor or use the quadratic formula. But let me go ahead and distribute my 2x. So I get 2x squared plus 18x plus 3x squared equals 8. Now, because I can see that this is going to be a quadratic, I'm going to get all of my terms on one side. In order to solve a quadratic, I've got to have it equal to 0. So I'm going to combine my like terms, which would give me 5x squared here, plus 18x, and then I'm going to subtract that 8 from both sides. So minus 8 equals 0. Now I've got a quadratic. I should be able to factor that. I believe it'll factor. I didn't look at the answer to this. I believe that'll factor, and then you'll have your 2 solutions. The one thing that you want to watch, and I don't think this will happen here, you don't want to get a solution that's going to make your original expression have a 0 in the denominator. So looking at that, the only thing that would make me get a 0 in my denominators would be if I had a negative 9 for x, because then that would make this negative 9 plus 9, which is 0. Okay, so yeah, and then this would be 81 minus 81, which is also 0. So we don't want to use negative 9. So if I finish solving this and I get negative 9 as my solution, then I know that's not a proper solution. I throw that one out. I don't put that into Delta Math as a solution. I'm not going to factor this right now unless there's a huge cry for factoring, only because I wanted to focus more on the process of solving the rational equation than the actual factoring piece of it. Yeah, I've got another one, Jerry. Ask and you shall receive. I'm ready. Okay, so with this one, we've got three fractions again. They're all fractions. They all have denominators. What I need to do is sort of compare what I see that's the same and what's missing. So because this is a binomial, guys, that's something that we can't kind of separate. Okay, so what I mean is this. Some of you maybe looked at that and said, oh, they all have an x. So I just need to subtract 1 from this one. No, that's not how that works. You can multiply top and bottom of a fraction by something and not change the value of that fraction. But if you subtract 1 from the top and bottom of a fraction, that could theoretically change the value of that fraction. So in order to get denominators the same, I need to look at the fact that, hey, these are they both have a factor of x minus 1. I don't see that in my first fraction, which means I've got to multiply top and bottom by x minus 1. Okay, so now they all three have an x minus 1. But this first fraction also has an x as a factor. So that means I'm going to have to multiply top and bottom of both of those other fractions by x. And now when I look at all of my denominators, they're all the same. So let me show you, and I'll do this the long way here. In my numerator, I have x minus 1 over x times x minus 1. Resist the urge to cross that giant 1 out because that'll just take you back to what you started with. Plus 4x over x times x minus 1. And then equals negative 8x squared over x times x minus 1. So the step that I didn't show in all its detail in the last example, and I'll show here, is because I have common denominators in all of my fractions, now I'm going to go ahead and multiply every fraction by that common denominator. Okay, because I'm solving an equation, I can multiply both sides by the same thing. And that's all I'm doing here. I'm multiplying the left side and the right side by the common denominator. So what that looks like is I'd have x times x minus 1 over 1. I'm just showing you the process here. Don't know why I put that there. So now I can start to look at the idea that the whole point in doing this process of getting the common denominator and then multiplying by the common denominator is so that you can get rid of your denominators. That's our big goal. So now I've got these giant ones that I can start to cross out. And what that does is it leaves me with a very simple equation. It leaves me with the equation that is going to be x minus 1 plus 4x equals negative 8x squared. So let me write that. So I'd have x minus 1 plus 4x equals negative 8x squared. Now once again, I'm noticing that there's a squared here, which means I'm going to have to solve a quadratic. And that's part of what I think level 3 was. You typically resulted in a quadratic. So I need to have one side of my equation be 0 and everything else be on the other side. Now I could subtract everything on the left side, put it on the right side, but I see that my squared term is negative and I don't like that. So I'm actually going to add 8x squared to both sides. So I'd have 8x squared, and then when I combine my like terms there, I'm going to have plus 5x minus 1 equals 0. And then once again, try factoring. I don't know if this one will actually factor, but you should be able to use the quadratic formula to solve this if needed. But the process is really what I'm trying to kind of show you here, is how do you get the fractions to really be gone? That's the key. So are there any other questions, anything else you wanted to ask about these?